Hello classmates, welcome to week 2 of Introduction to Music Production. My name is John Duff and today I'm going to speak about analog to digital conversion, or quantization. As we have learned in the first few weeks of our course, analog to digital, or ATD converters, work to continually measure the amplitude or volume of incoming sound waves and output these measurements as a long list of binary bytes known as samples. In this way, a mathematical picture of the shape of the wave is created. This picture contains the information which provides us with amplitude, frequency, and timbre. When we speak of the abstract phenomena of amplitude, we are referring to the compression and rarefaction of sound pressure levels of an analog signal, which we measure in decibels. The computer will use a process known as quantization to capture or sample amplitude levels over very tiny bits of time. The rate at which these samples are measured is known as the sample rate. The higher the rate, the more detailed the resolution of the audio picture. The intensity level to which the amplitude is measured is determined by the amount of binary information or bit depth that is collected at each given measure of time. In 16-bit CD quality recording, there are over 65,000 levels of which to record a sound wave's amplitude, each 1/44,000th of a second. If a wave's amplitude doesn't fall exactly at one of these 16-bit points, rounding up or down, known as dithering, occurs. Much like the brain does natural dithering with this photograph, small amounts of white noise are introduced into the sound to offset quantization errors. In order to obtain the optimum recording of analog sound in the digital realm, one must address the nyquist frequency. Because high-frequency sounds have thousands of cycles per second, we need at least 2 samples per cycle to obtain optimum resolution. This equates to a 2-to-1 sample rate to frequency ratio known as the nyquist frequency. For example, in order to accurately quantize a sound with a frequency of, say, 15 kHz, that's 15,000 Hz, the nyquist frequency would be at least 30 kHz, or 30,000 Hz. Recording with a lower sample rate will produce erroneous signals in the audio recording. CD quality is really the industry or minimum standard. However, many professionals do work in the 48 kHz realm for that extra detail. When too low a rate is used, the DAW software encounters a type of sampling confusion. Folding over, known as aliasing, occurs to address these unaccounted for frequency levels. Although the world of music production includes a number of complex terms and concepts, by breaking these terms down in logical, formative ways as set forth by Mr. Loudon Stearns, it helps us to process the complexities and decipher confusion at higher sample rates in our own minds. I hope you have found my presentation helpful and informative. Thanks for watching.